Does one of them feel more correct than the other?
No.
And or where do these emerge from? Okay, so what's the root, or where does this come from?
Let's start with n. It only starting n minus 1.
Okay, clarify why and how and what explains getting to 5n plus 10.
If you start with n.
You start with n and then you do what?
N plus 1. N plus 2.
Okay, n plus 1, n plus 2, n plus 3, got number, n plus 4, okay? And so, so again, we as teachers jump fast, right? We're skipping all sorts of steps and whatever, right? For kids, they'd be in different places, right? But we're saying 1 plus 2 plus 3 plus 4 gives us our 10, so we can see that is this, there's an interesting point. Is this a deductive route to this expression? Okay. Comment, question?
Yeah, I wanted to look at it differently. Let's say you don't look at n from n to n plus 4. You can look at the other way. You will get n minus 1.
Okay, you want me to write n minus 1?
It's on the other side, though.
Oh, okay. For this one? Here? N minus 1?
N minus 1, n minus... n minus 2, n minus 1. I'm trying to get to 5 and I couldn't see.
Okay.
It's n minus 1 plus n plus 1 plus n plus 2.
Okay, wait, so here's a number, here's a number, here's a number.
N plus 3, n plus 2, sorry. N plus 2, n plus 3.
4 numbers.
I forgot to do that. 3.
Okay.
Then you would combine my terms.
And it works.
Yeah. Does that get us to this expression?
It's just, a kid would not want to come up with that.
Kid wouldn't come up with that. Why might a kid still get to that? What's the rule they might have come up with for 3?
Or then
3n plus 3. And if they were seeing, we don't know. But if they were seeing, oh, these odd consecutives, I can do something, they might have just, that would have been a kind of inductive path to 5n plus 5, or 7n plus 7, or 9n plus 9, or so.
What would happen, they would end up with trouble when they get to n, they wouldn't be able to get all the numbers consecutively from n to get to the total.
Well, when they get, okay, so let's see what happens. Here it is. So 5n plus 5, well, it wasn't working on this one. What if we were on the number 65? Okay? So let's just create that. Let's suppose we had 5n plus 5 equals 65. Go ahead and work that out at your table. See what happens. How might the kid walk through this? What would they be able to find their 5 consecutives?
Let's start with the letter.
What does n equal?
12.
Yes.
N equals 12. Would they be able to find them? They might even do some trial and error in finding things, right? Maybe they feel like, well, n is one of them, and they might, I don't know, right? I'm sorry.
Let's clarify that misconception. See, going back to the definition of consecutive integers increase by 1. Increase means addition. So if you put that n minus 1, then n, and you add it and you subtract it. This is the big misconception.
Well, wait. So
misconception: consecutive integers increase by 1. Consecutive is in that order of
so this may not seem like the.
That means even you start from the point.
No.
Start from the, you don't start and go back.
We're just saying.
Okay. What if you're?
My problem is, or my concern is, n minus 1, then you go plus n, then n plus 1, and you don't see, you can't get any mathematical conjecture to fit into this category.
I think there might be a couple of things going on here. Actually, go ahead. What's the?
One of the things that I've noticed that we don't really do with students anymore is actually defining the variable. If you're defining the variable as n, and you have a variable that says n minus 1, then that means that's that number minus 1, not that number plus 1. So that, I don't know what you mean by misconception.
Okay, so I think that one thing I would add right now, first of all, the definition of variable is an interesting point that also might have connected up here too, right? But here, I think the reality is that when most of us were working through these problems, did anybody start with an n minus 1? No, we kind of used our own mathematical place to say, okay, she's asking me, is this illegitimate for any reason? And I can prove that it works, right? So our natural way of listing consecutive numbers is probably not to start here, but this is correct. This is mathematically correct. It's just not our habit of how we would list consecutive numbers, right? So I'm just going to let that hang. Yeah.
You said the word habit. And like us as teachers,
right.
We have a habit of doing n plus 1. Our students
no, right.
do not have any habit of
correct.
at all.
Correct. Correct. They're absolutely, right? I mean, our students, could students get to this?
Yes.
You know, it's a question, right? It's a question. Let's think about our population. And this connects kind of to how we think about this curricula as well. They're not void of all algebra, right? They may have struggled in that course, but they're, you know, so you know, would I expect 70% of my students to have that independently? Probably not. Might I expect a handful of them to be able to actually get to something like this and start that into this problem? Yeah, I might get that. And then there could be interesting questions for me as a teacher about when do I have the student share this? Maybe I don't do this sharing always at the end. Maybe this sharing might have happened actually 10 minutes into doing the problem, so that now they've actually built up that tool of using it. So I think you're absolutely right? We're not going to expect these students to all be at all ready to go that. Okay, so let's see. Any other questions on kind of what we're talking about here? All that time and it didn't even work. Okay, 6 consecutives. Who did that one? Okay. So this is interesting. We see a 15 there, right? Okay. Can we think about where he's getting that 15 from right now? Yeah, we can kind of see it, but we're math teachers. For a classroom, we'd probably want him to show a little bit more about where something like that might come from if we're even getting to that. But go ahead, share a little bit of what you have here.
Well, I started the n plus 1 and plus 2 until I get 6 terms. And after I added the n, I get 6n plus 15. So I determined if you're going to have 6 consecutive, then the total 63 must equal to that. And then solve for n. And then start from there and then add 1 each time until I get term number 6. And
okay, do we check our answer at the end, or are we coming? Yeah. Okay. Let me ask. I'm sorry. Celeste.
Oh, yeah.
Hi, Celeste. Again, for students, you had suggested that the way students might sometimes be doing a problem like this is they might actually take it and divide it by 3, right? And then they kind of fiddle around with this to figure them out. does dividing by 6 and then fiddling around get us somewhere? Is there a logic to that? That might be where, if I took 63 and divided by 6, what's it getting me to?
It's not a middle number.
Is it? Okay, what is it? What is 63 divided by 6?
It's 10.
It's,
I mean, that one is different.
it's 10 point, it's 10 and a half.
Yeah.
So it's actually that.
Oh, there you go, yeah.
Okay, so who knows? That actually, we all went to the algebra. Kids might actually be kind of continuing this route, right? And do they fiddle around and see if they can get to it? If you can,
Oh, yeah.
They can use the calculator.
they can be using a calculator with this, right? Okay, 7 consecutives. Did you expect it to work? Some of you knew it was going to work, right? Okay. I think this is kind of a similar route here. We can again talk about things like what would it mean to divide by 7 as another approach. So 63 divided by 7 would have given me 9, and what's the relevance of that number in this?
In the middle.
It's in the middle, right? Yeah. So that issue of middleness could sometimes be what might take them also to something like going like this, right? And so on, right? That might actually take us. So there's some interesting routes there. Okay. Okay, I think we kind of, but did you know 9 was going to work? And are you convinced that his 21 numbers out there actually work? Or is he just trying to sell us a used car? What's happening? Huh?
A good one.
A good one, a good one. Okay. I think we can kind of, we're seeing a pattern, right? What did work for the odd numbers? We could think about issues on more numbers, right? So there's a little bit more, there's interesting questions about how we might, where we might go with this problem, and different things about where your students might be on this problem. Okay, so take a minute in your group. I've got a couple of questions that I want you to kind of think about. Okay, so kind of just a brainstorm right now. And maybe have somebody in your group jotting things down. What's the mathematics in what we've worked on? Okay, what's the mathematics? One of the things you do with addition. Right? That was something. Okay? So think through various stages of solving the problem. You can think about your own solutions. You can think about others that you've heard from other groups and people at this point. And then what's the prior content knowledge required for students to get anywhere on this problem? Okay? And then what was important outside of the content knowledge for students to succeed with this problem? Okay? So I'm asking in your group, go ahead and go through those questions, have somebody kind of jotting down for us. What are your thoughts? Okay? Brainstorm the list of what is the mathematics that is working.